Hi, this is Mr. Warden. I'm going to do a short video key for Do Now 13.1. And here's our first question. We're going to be applying this theorem. If a segment is added to two congruent segments, the sums are congruent. This is called the addition property. And we have this question here. I need to actually change this actual question. What we want to prove is AC congruent to BD? And the way we can prove that AC is congruent to BD is that AB and CD are congruent, and BD just adds this little bit of BC, and AC adds this little bit of BC to AB. So since we're adding, okay, the way to prove this is that we are adding, you want to explain that we are adding the same segment to two congruent segments. So the new sums will also be congruent. Sort of like if you have x and you have x and you add 3 to x and you add 3 to x, you have x plus 3, and x plus 3 is x plus 3. So since AB is congruent to CD and we're adding the same dang thing to both of them, the new sum is the same. So using theorem 7, which is the addition property, if a segment is added to two congruent segments, the sums are congruent. Okay, so if I have to type with my cold fingers, a segment is added to two congruent segments, the sums are congruent. Okay, and that's what we're doing. We're adding a segment to two congruent segments. All right, I need to go back and fix the wording on that one, but this one is all set. So here we're going to be applying Theorem 8. If an angle is added to two congruent angles, the sums are congruent. Okay, so we have congruent angles here, and we're adding this angle. So we know that TEV and XEW are both congruent, and this little mark indicates that they are congruent as well. That's a way of symbolizing it. Okay. So we want to prove that TEW, so this is TEW, is congruent to XEV. Well, TEW and XEV are both the sums of a congruent angle and an additional angle. So we're adding the same angle. So an angle is added to two congruent segment angles, the sums are congruent. So because we are adding the same angle to two congruent angles, the sums will be congruent. And that's basically what you need to communicate. All right. The third one, what could we prove and how? So we know that T is complementary to W. That means they add up to 90 degrees. We know that X is complementary to Z. That means they add up to 90 degrees. We also know that Z and W are congruent. So what can we prove? There's a few things we can prove. One thing we can prove is that V and Y are right angles. We could prove that V and Y are right angles or 90 degrees because T plus W equals 90 and X plus Z equals 90. And all that is left of each triangle is 90 degrees. Okay, we could prove that, okay, by algebra, basically, okay, or by subtraction, you could say, because we would subtract 90 degrees from 180, and you get 90 degrees. Okay, another thing we could prove is that angle T is congruent to angle X, because angle T and X, okay, also can prove that T is congruent T and X are congruent because they are complementary to congruent angles. Because Z and W are congruent, and T and X are complementary to W and Z, respectively. Therefore, T and X are congruent because they're complementary to congruent angles. There may be some other things that you might have noticed that I've left on the table, but that's the two obvious ones to me. Really kind of three obvious. V and Y are right angles, and then we could also say V and Y are 90 degrees. Actually, there's a couple more. TV and VW are perpendicular, and XY and ZY and XY are also perpendicular segments. You could prove that too. And you can keep going. I'm sure there's some more things. We could also prove that these two triangles are similar because they have all the same angles, and therefore their side lengths, corresponding side lengths, form proportions. We can't prove that the two triangles are congruent because having congruent angles is not sufficient to be congruent. It is sufficient to be similar. Okay, so triangles are similar because angles are congruent. Okay, later on you'll learn about the angle postulate. Okay, which demonstrates that. All right, I'm going to stop sharing, and I hope that helps.